Imagine a world where your thoughts could directly control your surroundings. Sounds like science fiction, doesn't it? But hold on to your seats, because this is not a page out of a Philip K. Dick novel. This is real, tangible technology. We're talking about brain-computer interfaces, a frontier being explored by the likes of Neuralink. In the simplest terms, these are computer chips designed to interface directly with your brain. They have the potential to revolutionize the way we operate, enhancing our cognitive abilities and allowing us to control devices with a mere thought. Imagine being able to access the internet, call a friend, or even operate your smart home, all without lifting a finger. This technology has the potential to change everything from healthcare to entertainment, and it's not just a pipe dream. Companies are actively developing these chips, pushing the boundaries of what we understand about the brain and technology. This isn't just a concept anymore, it's a reality we're moving towards. To truly grasp the potential of these computer chips, let's look at some real-life examples. One of the most powerful applications of this technology can be found in the treatment of Parkinson's disease, a degenerative disorder of the nervous system that primarily affects movement. It's a condition that can cause symptoms like tremors, stiffness, and difficulty with balance. Now, imagine a tiny device, a computer chip, that could help manage these symptoms. It sounds like something out of science fiction, doesn't it? But this is no fantasy. This is deep brain stimulation, or DBS for short. DBS involves the implantation of a small pacemaker-like device into the chest. This device is connected to thin insulated wires, called leads, that are guided into specific areas of the brain. The chip in the device sends electrical signals along these leads to the targeted areas of the brain, helping to control the erratic movements that are characteristic of Parkinson's disease. And it's not just about managing tremors. This technology can also help to alleviate other symptoms of Parkinson's, like stiffness and slowness of movement. It's a way to give people with this condition a better quality of life, to help them regain control of their bodies. But it's important to remember that DBS isn't a cure for Parkinson's. It's a treatment, one that can help to manage symptoms and improve quality of life. But it can't stop the progression of the disease. Nonetheless, the impact it can have on a person's life is profound. You see, these chips aren't just about enhancing our brains in some abstract, futuristic sense. They're about making real, tangible improvements to people's lives. They're about empowering people to take control of their health, to live their lives to the fullest, despite the challenges they face. So, computer chips aren't just enhancing our brains, they're giving people their lives back. But what about enhancing our memory, you might ask? Well, let's dive into a fascinating case study from the University of Southern California. In this study, a cutting-edge chip was implanted in the brains of participants, aiming to improve their memory. The process began with a group of volunteers who agreed to have a small chip no larger than a grain of rice implanted into their brains. The chip, known as a neurostimulator, was designed to mimic the way our brains naturally store memories. The neurostimulator works by recording the brain's electrical activity when a new memory is being formed. It then replays that same activity pattern to reinforce the memory. Essentially, it's like having a personal memory trainer living inside your brain. Now, you might be wondering, did it work? Yes, it did. The results of the study were nothing short of remarkable. Participants reported a significant improvement in their ability to recall information. The neurostimulator didn't just enhance their memory, it supercharged it. One participant, for instance, had always struggled with remembering names. After the chip was implanted, she was able to recall not just names, but also intricate details about the people she met, such as their hobbies and the stories they shared. Another participant reported an unexpected side effect. He began recalling long-forgotten childhood memories, reliving them in vivid detail. He described it as opening a door to a room full of memories he didn't even know he had. There were, of course, some concerns. The chip had to be surgically implanted, which carries risks. And there were questions about the long-term effects of the device on the brain. But overall, the potential benefits of the neurostimulator were considered to outweigh the risks. The takeaway from this study is clear. The potential for enhancing our memory with the help of computer chips is real, and within our grasp. It's not science fiction, it's science fact. And it's happening right now. Imagine never forgetting a name or a face again. That's the potential of these chips. With great power comes great responsibility. And so, we find ourselves at the crossroads of innovation and ethics. Brain-computer interfaces are no exception to this rule. As we journey deeper into this brave new world of technology, we need to ask ourselves some tough questions. What happens when our most intimate thoughts are no longer private, but accessible by a device? Can we guarantee that this technology won't fall into the wrong hands, leading to catastrophic misuse? And what about consent? Who gets to decide whether a person should have their brain augmented, and under what circumstances? These are not just hypotheticals. These questions are real, and they demand our attention now. The future is already knocking on our door, and we need to be ready to answer it. Not with fear, but with a well-considered understanding of the implications. It's a brave new world we're stepping into, and it's crucial we navigate it responsibly. So, what does all this mean for the future? Well, let's put it this way. We are standing at the precipice of a new era, one where computer chips could become the keys to unlocking untold potential within our brains. We've seen how they can offer a ray of hope to those suffering from Parkinson's disease, providing a level of control they may have thought lost. We've also explored how these chips can enhance memory, adding a new dimension to our ability to recall and retain information. But it's not all smooth sailing. The ethical dilemmas are real, and we cannot ignore them. The balance between advancement and ethical responsibility is a tightrope we must tread carefully. Yet, the promise is tantalizing. Computer chips could redefine what it means to be human, pushing the boundaries of our capabilities. The possibilities are endless, and the future is closer than we think.